Section 5.2 StatCrunch example. We're going to work on problem 39 from the ebook in section 5.2. In a presidential election, 611 randomly selected voters were surveyed, and 308 of them said they voted for the winning candidate. The actual percentage of votes for the winning candidate was 43%. Assume that 43% of voters actually did vote for the winning candidate, and assume that 611 voters are randomly selected. Part A. Use the range rule of thumb to identify the limits separating the values that are significantly low and those that are significantly high. Based on the results is 308 voters who said they voted for the winner significantly high. Okay, so the range rule of thumb, if you remember, first thing we need to calculate is the mean and the standard deviation, and I've done that down here. Remember, the mean of the binomial is n times p. In our case, the sample size is 611 and the proportion is 0.43, and if I multiply those out I get 262.73. The standard deviation is the square root of n times p times q, and I've gone ahead and I've put my numbers into the formula here, multiplied, taken the square root, and I get 12.237. The range rule of thumb says the lower bound is going to be mu minus 2 sigma, which is going to be 262.7, my mean, minus 2 times 12.2, and I end up at 238.3. And on the high side, I'm going to take mu plus 2 sigma, and I get 287.1. So the 308 voters is higher than the 287.1, which we got from the range rule of thumb, so we would say that 308 voters is significantly high. Part B says find the probability exactly 308 voters voted for the winner. So we're going to use StatCrunch, and I've already opened up StatCrunch. Remember how we did that? We went to our table of contents. In our My Stat Lab course, we clicked on StatCrunch, we clicked on StatCrunch website, and we clicked on Open StatCrunch, which I've already done. So what I'm going to do now is go to Stat, Calculator, Binomial, and I need my sample size, which if you remember from the problem was 611. And we said 43% of the voters voted for the winning candidate, and we want to know what's the probability that we have exactly 308 voters in our sample of 611 that voted for the candidate. And there's my probability, quite small, 0.1234 zeros and then a 4, so quite small. And then the part C wants us to calculate the probability that 308 or more voters voted for the candidate. So we're going to change our inequality here to greater than or equal to. We're going to push compute. And now we have 0.0001 when we round it off. All right, so let's go back to the problem, and what did it say? It says, which probability is relevant for determining whether the value of 308 is significantly high, the probability from part B or the probability from part C? It would be the probability from part C because we're calculating the probability of 308 or more voters. Based on the relevant probability is the result of 308 who said they voted for the winner significantly high. And yes, it is. And what's interesting is that the two results match up, and it also tells us that perhaps the survey results here are not going along with the idea that actually 43% of voters did vote for the winning candidate. In fact, perhaps more than 43% did.